Good morning. I'm Vijay Madhuri. Our today's concept is what is meant by this multiplexing. What is meant by this multiplexing? It is a technique which is mainly used to combine and send the multiple data streams over a single medium. Okay, that means whenever if we need a requirement of data transmission, then we use this multiplexing concept. That means here in this concept, the process of combining the data streams is known as what? Multiplexing. And the hardware which is used for this multiplexing is known as the multiplexer. Hardware which is used to the hardware which is used to for this multiplexing is known as this multiplexer. Okay, and in the next slide here, like whenever if we have like what is meant by this multiplexing, multiplexer, everything is very important. This multiplexing, it is mainly achieved by using a device called multiplexer that combines n input lines to generate a single output line. Okay, that means whenever if we have this multiplexing, we have here, I already explained in the last slide, the hardware which is used for the multiplexing is known as multiplexer. Okay, hardware which is used for the multiplexing is known as multiplexing. And here we have n input lines. Okay, and to make the n input lines into a single output line, we are going to use this multiplexing concept. Understand? And next here, now what is this demultiplexing? In the multiplexing, we are going to make many to one. And in demultiplexing, we are going to make one to many. That means demultiplexing is achieved by using a device called demultiplexer. Okay, this means this in this demultiplexing, here once we receive the data from many inputs to the one line. Okay, and in demultiplexing, what happens? That is going to be the one is going to be divided into many. Okay, that's why we are going to call it as a one to many approach. Okay, and here in this multiplexing, mainly we have three different types of multiplexing. One is a frequency division multiplexing, another one is a wavelength division multiplexing, another one is a time division multiplexing. Here in the time division multiplexing, we have synchronous time division multiplexing as well as the asynchronous time division multiplexing. Here, whenever we have all these things, in this the very important one is like time division multiplexing. Okay, and next here, first we'll learn about what is meant by this frequency division multiplexing. In this frequency division multiplexing, what happens? Here it is mainly an analog technique. Okay. And in this frequency division multiplexing, it is a technique in which the available bandwidth of a signal transmission medium is going to be subdivided into several channels. For example, here in this frequency division multiplexing, mainly it is a technique in which the available bandwidth of a single transmission will be divided into several channels. For example, here 1 to 5 as one device, 7 to 12, 14 to 13. That means it is going to divide into equal parts as a frequency. Then the transmission is going to continue. Okay. And here in the above diagram, a single transmission medium is subdivided into several frequency channels. You just see, here I have one frequency range. It was divided into several channels. Okay. And here the device 1 has a frequency channel of range from 1 to 5. And the input signals are translated into frequency bands. Okay. And by using this modulation techniques, and next here, like in the same manner, the data is going to be transmitted by dividing. The main aim of this frequency division multiplexing is what? It is going to subdivide the available bandwidth into different frequency channels and it is going to allocate to different devices. Okay. And the main example where we use this frequency division multiplexing is what? Here mainly we'll use in radio broadcast and also for TV networks. Okay. And see here, in this we have n number of sources. That means always we have the many to one transmission. Okay. And the bandwidth is divided into n number of frequencies. Okay. This is one of the example for the frequency division multiplexing. And what are the advantages and disadvantages of this frequency division multiplexing here? In this frequency division multiplexing, it is mainly used for analog signals. Okay. Whenever if we have the data transmission through the analog signals, then we use this frequency division multiplexing. And what is this process? It is very simple and easy modulation. And a large number of signals can also be sent through this frequency division multiplexing. And it does not require any synchronization between the sender as well as the receiver. But whenever if we have advantage, we have the disadvantage is what? We may have a problem of this crosstalk and the speed is also less and the number of modulators is also more and it requires a high bandwidth channel. Okay. And in this, the next one is the wavelength division multiplexing. As in the previous diagram, I told we have three different types of multiplexing: frequency division, wavelength division, as well as time division. In this wavelength, what we have in the wavelength division multiplexing, here it is going to divide, okay? And here, see here, this wavelength division multiplexing means it is same as frequency division multiplexing only, but except the optical signals are transmitted. Okay, here in this wavelength division multiplexing, what is happens? It is used on fiber optics because whenever if we have the data transmission through fiber optics, the speed will be more. Okay, and the data transmission is also more speed. And it is used to utilize a high data rate capability of fiber optic cable. And it is an analog multiplexing technique. And the optical signals from different sources are combined to form a wider band of light with the help of multiplexer. And next here, like it is a multiplexing and demultiplexing. In multiplexing, what happens? From multiple channels, the data is transmitted from many to one. And here in demultiplexing, it is divided into three or more. It is one to many. Okay. And the one of the very important multiplexing technique is what we have? This time division multiplexing. In this time division multiplexing means here, whenever if we have a frequency division multiplexing technique, all signals which are operated at the same time with a different frequency. But whenever if we are working with this time division multiplexing, here, the total time available in the channel is distributed among various different users. Okay. Therefore, each user is allocated with different time interval. Okay. That means, see here, based on the requirement, based on the need. Okay. Then the time slot is going to be allocated to each and every center. Okay. And the user takes the control of the channel for a fixed amount of time. Whenever if we have this time division multiplexing technique, the data is not at all transmitted simultaneously. Okay. And in this time division multiplexing, here what we have, here we have the different signal. The signal is transmitted in the form of frames and the frames contain a cycle of time slots in which each frame contains one or more slots which is dedicated to each user. And it can be used to multiplex both digital and analog signals, but mainly used to multiplex the digital signals. And I already explained in the first diagram, as we have, whenever we have this multiplexing, we have frequency division, wavelength division, as well as time division. In the time division, we have two different types of transmission. One is a synchronous time division multiplexing, and another one is a asynchronous time division multiplexing. Whenever we have this synchronous time division multiplexing, in this, what happens? This is one of the best technique. And in this synchronous division and multiplexing, it is a technique in which the time slot is pre-assigned to each and every device. Okay. And also in this synchronous time division multiplexing, each device is given some time, irrespective of the fact that the device contains the data or not. Okay. And if the device does not have any data, then simply the slot will be empty, but it does not it does not give the slot to another. Okay. And in this synchronous time division multiplexing, what happens? The signals are sent in the form of frames. Okay. Here in this, the signals are sent in the form of frames. Each and every frame contains a number of signals. Okay. And that means the number of time slots. Based on the time slot, the signals are going to be transmitted. Okay. And there are n devices, then there are n slots. You just see here, if I have n devices, then I have the n slots. Okay. And here Next, whenever if we have the synchronous time division multiplexing, for example, here I have a transmission of A. Okay, that means for each and every frame I have the different time slots, but here I don't have this C value to be transferred, but the slot is empty. Okay, it does not adjust the slot with other. Okay, you just see here in this figure what I have given. Just see here in this figure, for example, in the above figure, what we have done in the synchronous time division technique, it is implemented. Each device is allotted with its time slot. Okay, the time slots are terminated irrespective of whether the sender has to send the data or not. You just see here, this time slot is empty. Here also it is empty. Either it is empty or not, but slot is going to be given to the particular frame. Okay, here each and every frame, the slot is going to be given. Okay. And whenever if we have the disadvantages of synchronous transmission here, the capacity of the channel is not fully utilized. Okay. Here, whenever if we have the synchronous, the capacity is not going to be fully utilized. Okay. And as the empty slots are also transmitted, which is having no data. Okay. And the speed of the transmission medium should be greater than the total speed of the input lines. Okay. And next, whatever we have this asynchronous time division multiplexing. This is also known as statistical time division multiplexing. Here in this, here, just see. Now explain, let me explain. Here in the time division multiplexing, it is a technique in which the slots are not fixed as in the case of synchronous time division. Time slots are allocated to only those devices which have data to send. Okay. And therefore, we can say that asynchronous time division multiplexer transmits only the data from active workstation. Just see, in the synchronous, if the data is there or not, it is going to be created. But here, based on the activeness of the element, then automatically the asynchronous data transmission is going to be done. Okay. And here, and the frame of the above diagram can be represented like this. Based on our requirement, automatically we'll get the data. Okay. And we'll see in the next class with the next concept. Okay. Yeah.